Well, hello everyone, and welcome to our presentation on automation, DevOps, and security. We actually have a lot to cover today, so let's just go ahead and get started. Okay, so for agenda, we're going to cover the principles of DevOps in the cloud, unpack a few components of an automated environment, and explore how one of our customers benefited from an immutable infrastructure. Then we'll end by wrapping it all up by reviewing the impact of automation in security. So a bit about me. I'm a certified multi-cloud architect here at Logicworks, about 12 years of IT experience, born and raised in Kingston, Jamaica, and I'm learning to fly a Cessna 172. Now, Logicworks is an AWS Premier Partner, Azure Expert MSP, and a leader in the migration and managed services for highly regulated industries. Now, we often work with customers seeking to improve their security posture through automation and have created an entire cloud reliability platform that currently protects over 5 trillion financial transactions yearly. Now, by leveraging a software-driven approach to cloud management, the team here at Logicworks is able to act as a force multiplier for businesses by automating security, governance, and compliance. So over the last year, we've seen a sharp increase in businesses leveraging the public cloud to gain a competitive advantage, right? Teams that are responsible for managing cloud assets are painfully discovering that applying their legacy approach to managing cloud resources acts more as a blocker. It's becoming increasingly challenging to manage all these systems, especially as applications become more distributed. So the question we often ask ourselves is, how do we manage constant change within our infrastructure? And not only manage the constant change, how do we allow for rapid development and deployment of new application features? The only way we can really do this is through automation. When a company truly embraces automation, they can innovate faster and they often tend to outpace their competitors. When working with customers on cloud initiatives, I first like to really understand what are the business objectives, right? As I find that paves the way to define more clearly their IT objectives or their technical objectives. Now, typically, their objectives fall within one of these 4 areas, and for some projects, they actually encompass all 4. So from modernizing the system components and tools to enable rapid deployment of applications while scaling those applications to meet customer demands, to improving the security posture of the organization to not only prevent an attack, but I also believe as IT professionals, it's our responsibility to be proper stewards of the customer's sensitive data. Now, companies migrating to the cloud often seek to improve their operation excellence. They want more resiliency, they want higher availability, they want more reliability for their IT assets. But when it comes right down to it, businesses are seeking ways to save money. And one guaranteed way to save money is to really reduce how much it costs to produce. Okay, so when I worked in a data center as a system engineer a long time ago, our solution to solving most problems were really to just throw money at the issue. We tend to purchase more hardware for performance, not really trying to optimize what we already had. We throw human resources, well, engineers specifically, to solve challenging problems. We wouldn't seek to innovate or apply automation. And we would spend weeks creating complex processes that did absolutely nothing but create a red tape of entanglement that slowed down innovation. So as we approach the cloud, we need to shift our mindset and adopt a cloud-driven approach to not only migrating resources to the cloud, but managing the infrastructure and the deployment of services in that new infrastructure. So let's take a look at some of the main points, or main principles, I should say, of DevOps. First is designing your cloud infrastructure to support constant change. As more and more companies adopt an agile approach, long gone are the days, or I shouldn't say long gone, there's still some companies using a waterfall approach, but you'll find more companies are using an agile approach for application development. Applications are no longer updated once a month. Rather, most modern applications are updated daily or multiple times a day even. to support the need to apply these application updates and these updates for system components, um, each component, instances in this case, must be able to be built in a repeatable manner. We want to eliminate any snowflakes within our environment. Through the use of the cloud, we can achieve reliability from a hardware perspective, right? In the modern era, all end users, they're truly expecting 100% uptime. And the last thing you want to do is lose your most valuable customer to a competitor due to reliability issues. Just this morning, some of you may have noticed US West 1 and West 2 were down for 30 minutes. So if you're not planning for failure and making sure that your system is able to absorb failure, then you would see a degradation in service. AWS provides all the tools necessary, but it's up to us to piece those tools together to maximize the uptime for our services. Now, the more human touch points you have in your process, the more risk you take on from a security perspective. We are far from being perfect after all. Well, humans are imperfect beings. So it just takes one oversight to bring down an entire system. Maybe you woke up this morning, didn't get enough sleep, or you didn't get your morning cup of coffee. So you're not really firing on 100%. I've seen far too often for many different environments where security groups and S3 buckets that hold sensitive data for customers are just open to the world, as you saw for the previous presentation with Cloud Health. So as we design for constant change, we must also prepare new environmental builds. So this is your QA, your dev, your staging, and UAT environments, and taking a manual approach to that is just not efficient. Also, while we build these new environments, we also have to frequently update the applications and infrastructure components supporting these environments. Preparing for instance failure, we talked about that earlier, or scaling your instances to meet service demands presents its own set of challenges by leveraging a manual approach, as well as accelerating code deployment without compromising on security. Our main goal here is to maintain a known good security state without needing to involve the security team during every update. Now, I love the GUI like anybody else, but the process to deploy a new environment using the GUI just doesn't scale well. For a second, just imagine you're managing a healthcare SaaS platform that processes terabytes of hospital patient data, where there's a requirement to support not only multi-tenancy, but also single tenancy. Deploying the infrastructure manually will significantly slow down onboarding of new customers to our platform. And this would lead to configuration drift between all our different environments. And at that point, we start getting those emails with a red exclamation mark from our security team filling our inbox. We definitely want to avoid that. So by using pre-built templates, we can rapidly deploy new environments, and by leveraging configuration management solutions, we can bootstrap the operating system with pre-approved security configurations. You want to shift security closer to the left of the build process and bake security in as early in the process as possible. So let's look at a typical automated build. In this case, we're using CloudFormation as our ISC tool, and the CloudFormation is going to deploy the foundation for infrastructure. So think it's going to build a VPC, it's going to create the security group with the correct roles or internet gateway. It's going to lay the foundation for infrastructure. And not only that, it's going to actually launch our AMI. When the AMI is launched, actually before the AMI is launched, we're actually going to pass in some user data that will boot the installation of our Puppet agent. And Puppet is the configuration management tool that we're using in this case. Once the agent is up and running, the first thing it's going to do is reach out to the Puppet master. It's just another node that houses the configuration for our instances, and pull down the, whatever predefined configurations you defined in the manifest for Puppet and apply those configurations down to the instance. So this is all an automated process from building out the underlying infrastructure to support the instance to applying configuration changes to the instances all in one seamless pipeline. So similar to what we covered in launching a new environment, performing manual updates to distributed systems significantly increases risk if these operations are performed manually. It's just prone to too much human error. There's a higher risk for each change that is made to actually take down different system components, and making those changes manually, especially for large environments, consumes precious engineering time. And then there's a question, if an update goes wrong, how do we roll back the infrastructure, which is always a challenging one to solve. By describing our infrastructure as code, we can apply a software-driven approach. This means we no longer have to log in manually to individual servers and apply these changes. Rollbacks are simplified to just changing a configuration variable within our code, and updates can be applied to all instances or maybe just a subset, a small group of instances if needed. Now, in response to instance failures within a system, the legacy approach involves sending an engineer, an engineer receiving a notification, and then the engineer will log into the instance and try to determine, okay, what's going on with this instance? What's the root cause? And if they can't figure out the root cause, then that instance has to be rebuilt. Now, this manual process is very time consuming and can significantly affect downtime, especially if multiple system components are affected. Rather, it's best to design for failure from the beginning, right? So you want to use automation where we can to automatically fail over resources to multiple availability zones. We want to be able to trigger automatically the rebuild of new instances, and during that rebuild process, we also want to make sure that we're deploying the most recent version of our code to that instance in an automated way. Now, it's important to test your environment for resiliency. It's great creating this wonderful architecture when an initial build, but if you don't test your environment, you're literally planning to fail. So we want to take a proactive approach to security, and that's exactly what Netflix has done by creating this solution called Chaos Monkey. Just imagine, your monkey inside your data center. You give it a big wrench that's going on and just smashing all your servers. That's essentially what it's doing in your cloud environment. This gem of a tool, what it really does explicitly is terminates your instances randomly. So think if you have a 3-tier web application and someone just going in just turn off a web server, turn off an application server. How does your system as a whole is able to respond to that kind of disruption? And by using Chaos Monkey, we can fine-tune our practices to ensure system resiliency for our applications. Now, for developers, it's a bit different, but same idea applies. Manually deploying code presents a higher risk of error and has a potential to impact and bring down the vast majority of systems, right? There's also a challenge of managing the conflict between application packages and updates across a fleet of distributed systems. And we start thinking multi-region, the complexity just compounds. Through the use of AWS Service Catalog, what we can do is create pre-approved templates that allow developers to be more or take more of a self-service role in deployment of infrastructure, removing operations as a blocker and really creating that push-button deployment method. In traditional ITIL methods, we really have to put in a change request and then wait maybe hours if your IT organization is really streamlined. But in most cases, you're waiting days or weeks just to spin up new resources for your developers to test out functionality or features before the code is committed. What we're trying to do with the DevOps methodology here is empower our developers, remove roadblocks for allowing them to quickly innovate for our teams. Okay, so here's a high-level view of a deployment pipeline. Let me walk you through some of the components here. First, we're going to use or leverage, I should say, AWS Catalog to launch our pre-approved templates. In this case, we're using the Elastic Container Service from AWS, and GitLab will be our version control system. So once our code is committed to maybe a branch that's tied to development or a branch that's tied to prod, or maybe the code is committed to master. We're going to build an image by pulling down the base image from Docker, using Jenkins to perform the CI for us, a continuous integration to build that image, push that image back up to a container registry, and also leverage Jenkins to deploy that solution or deploy an image rather to the container service. So all in one pipeline that is seamless and integrated. And once we deploy to the container service, ECS will manage the placement of the containers for us. We don't have to handle that. Now, no one really likes having to fix a server, especially at 2 a.m. It's time consuming and can be very expensive. So why would we ever want to fix a server when we could just replace it with a fresh build? Now, that idea has led to the development of what's known as an immutable infrastructure, and it offers a few different benefits. For one, you can prevent configuration drift from a known good state. It also allows you to verify the failure process is working as intended and allows IT teams to become more familiar with the failure process. So they're able to respond quickly to live events. So we want to think, well, if a failure happens in our environment, one of our nodes goes down, is our IT team, able to quickly respond to that failure? Essentially, have they had enough practice, failing over to a different AZ, failing over to a different region, spinning up these resources as quickly as possible so we're minimizing the impact for our end users. But using this method does require a full automation of the instant boot process. Typically, we're leveraging fully baked AMIs where all the code and all the applications and all the security controls are already packed tightly within that AMI image. So it really just takes minutes to spin up an entire new infrastructure from that base AMI. One of the customers that we worked with, it was a backup software company, hosts critical data for a large number of Fortune 500 companies. They were experiencing rapid growth, but as often the case where a company experiences rapid growth, they tend to overlook security and didn't implement proper security controls and reliability controls, putting petabytes of customer data at risk. They were also rolling out a new application and new services and features and wanted to test the viability of an immutable infrastructure. We were able to partner together with this customer to first codify their infrastructure because they were using a manual deployment process and created different codes and templates for the different projects, for the different teams that automated the build of new instances and services. In addition to that, since we're using an immutable infrastructure, the environment could be torn down and rebuilt multiple times a day, and it only took minutes. So from a support perspective or engineering perspective, having that familiarity with failure makes it easier when everything is going red for the team to quickly respond. They're not scrambling trying to read old, outdated documentation how to recover from a failure. It's been practiced. It's ingrained throughout the entire IT process. In addition, we created a catalog of services so developers were able to be more empowered to self-service their deployments of the infrastructure. And all the templates that are in the catalog are already pre-approved by operations and security. So it really removed those roadblocks from our development team. Now, this resulted for our backup company in a 0.001% instance failure rate, which is remarkable. Nearly 100% uptime of their applications. Push button deployment to production with a single click without further instance configuration. And taking all these benefits together, it really led to improving deployment efficiency by around 60%. So now you think this backup company probably has different competitors. The ability to out-innovate your competitor really makes a difference in how you stand out different from the market. Now, automating security allows us to protect us from ourselves, really. We are the greatest risk when it comes to security these IT resources. Through the use of automation, we can prevent human error by standardizing the build process and the update process by expressing those standards as code. And this results in little to no direct human interaction with the environment, which is something we're trying to strive for. We don't want too many people in the cookie jar, right? Now, patching instance becomes almost trivial leveraging a DevOps and automated approach. With patches applied centrally, typically to a base AMI that is shared out and used to build other systems across different regions and even into different AWS accounts if you have a multi-account strategy. This provides consistency across your environment. And if on the odd chance a resource is launched with old version of our configurations, then our configuration management solution will auto remediate those configurations, bring it more in line to what we described or declared in the manifest to prevent configuration drift. Now here we see a typical three-tier application deployed across multiple availability zones. Unfortunately, we have a security group that was misconfigured and exposes our application to the world. Now for a small environment, it may be easy to identify a misconfigured security group and remediate the issue, but what if your environment looks a little bit like this? This slide is a bit more busy, but as our environment grows, we can see it becomes a significantly more difficult challenge in identifying the security gaps. There could be hundreds of security groups, each with their own set of rules for what traffic is allowed inbound to the instance. Where do you even begin to look? And in just this example here, we have about 40 security groups. And this is under the assumption that this is production only. We haven't even considered the lower tier environments like development, staging, UAT. So it can really compound the larger your infrastructure is and the more distributed your applications become. It's always best to leverage automation where possible by using a combination of configuration management and, for example, the AWS config service. We can quickly identify and remediate most configuration drifts in your environment. So it's a really powerful tool. Now, I always recommend companies encrypt any sensitive data stored within the cloud. And I know it's kind of obvious, if you worked in the cloud for any period of time, you should know this, but it's truly a shared responsibility model for the resources, or rather the data that's stored within the cloud. Here we see an example for an S3 bucket policy that denies uploading any unencrypted object to that bucket. In this case, we're using AES 256 as the encryption filter. To minimize security exposure, it's always a best practice to encrypt all EBS volumes that are storing sensitive data. That's your encryption at rest. And if data needs to go across the wire, we want to encrypt that data in transit as well. We can use a security protocol like TLS to achieve that. So as we talked about earlier, we can leverage automation to accelerate innovation. We can detect and recover from unexpected failures easily. And the great thing about security and all the topics I talked about earlier today is that you don't have to do it all right now. Any step forward is great. I suggest starting with really ensuring all your data is encrypted. As a user myself of different SaaS platforms that are housing highly compliant data like HIPAA or PCI, I would feel safe knowing that all my data is encrypted at rest and encrypted at transit at the bare minimum, especially knowing that S3 buckets are prone to misconfiguration, so to speak. I'm sure we've all seen a few different articles on companies with security breaches for the S3 buckets, but it can quickly get away from you if you're managing hundreds of S3 buckets with multiple different objects without any automation. It's too much for one person or a team of engineers to handle. Now, if you don't have the bandwidth to automate your infrastructure, or you just don't know where to start, Feel free to reach out to us. We've worked on some amazing projects helping customers that have financial regulations and healthcare regulations to automate the process of deploying new resources to a highly compliant infrastructure while still achieving their being able to achieve their audit and accelerate their growth as well. So with that, we come to an end, and I'd like to thank everyone for your time and attention. Again, feel free to reach out if you have any questions around how Logicworks can help you automate and achieve, well, achieve a DevOps proficiency within the cloud.